Hey guys, today I'm going to be doing a quick video on chylomicron lipid transport. This is going to be in a series of videos where I cover HDL metabolism, VLDL metabolism, as well as chylomicron metabolism, which is going to be today. Because I didn't want to make a 30-minute long video on all of them all at once, and this helps you separate the concepts out in your brain a little easier. So, chylomicrons are the main transporters of something called triacylglycerols, which is just a glycerol backbone with 3 fatty acid tails, and it is the main way that your body takes up fats. And so when you eat a meal that's high in fats, you have all these triacylglycerols in your small intestine, which I've labeled here as gut, and you want to move them to your target cell, which I've shown here, right beside our capillary, for simplicity. So to get out of the gut, you need to first go into the lymphatics. And the body does this by using a protein called MTP, or microsomal transfer protein. This protein is very important because it not only helps to move chylomicrons out of the gut and into the lymph, it also adds a lipoprotein onto the chylomicron called ApoB48. And this is very important. So you got out of the gut, MTP acted on your triacylglycerols, stuffed them into a chylomicron, and put ApoB48 onto the surface. What ApoB48 does is it now allows the chylomicron to move from the lymph into your capillaries. So here we have the lymph, and we can now move into the capillaries due to ApoB48 acting on specific receptors. MTP in the gut puts ApoB48, moves tags into your chylomicron, and it now can go into the capillaries. Once in the capillaries, I think it's better drawn out down here. So we have our lymphatics to our blood, we have our ApoB48 on there, and we're going to gain another couple important apolipoproteins required for chylomicron transport and metabolism. These are gained by taking them from HDL. So HDL is a known donor of 2 very important apolipoproteins called C2 and E. So now our nascent chylomicron, which just had ApoB48, is in the blood, interacts with HDL, and gains these new apolipoproteins E and C2. And you'll see their functions in just a second. So our chylomicron is trying to get these tags, which it's carrying, into the cell. Well, it can't just do that without the action of another protein, so it's going to need the help of this enzyme called LPL, or lipoprotein lipase, which will cut the chylomicron open and transfer the tags into your target tissue cell. And LPL requires one of these apolipoproteins in order to become active, so it looks for C2. Once LPL finds a chylomicron or anything else with C2 on it, it's going to act to cleave it and transfer tags to your target tissue cells. That's what C2 is for. Now your chylomicron has done its job. It transferred a bunch of tags into your cells, and it also has not only tags but a lot of lipid-soluble vitamins in there, some cholesterol esters, which need to be put somewhere. So where are those stored? Well, those are going to be put into the liver after your tags have been transferred. And how does this happen? So your LPL cleaved off C2 in the process of cleaving the chylomicron, and C2 got returned to HDL, and so what are we left with? We're left with ApoB48 and ApoE. Now what's the importance of ApoE? ApoE allows the chylomicron remnant at this point, this is what it's called after it gets cleaved of its tags, this is a remnant, and ApoE allows it to react with the liver remnant receptors and get taken up. So the liver is a storehouse for a lot of cholesterol, which is then redistributed using HDL and VLDL, but we'll get to that in the next video. So ApoE acts on the remnant receptors. Another thing that I forgot to mention was that LPL has different types of actions depending on where you are in the body. So for example, LPL is an enzyme that is insulin dependent if you are in the heart. So higher insulin levels, your body needs more energy, your LPL is going to be more active. So places like the heart, muscle tissue, insulin-dependent LPL. But if you are in an adipose kind of tissue, so if you're in fat-rich areas, those adipose tissues are meant for lipid storage. So they store a lot of triacylglycerol. These areas are insulin independent, so it doesn't matter if you have insulin or not, they're going to take up the triacylglycerols and store them in your adipose cells no matter what. Alright, I hope this video helped, and I'll see you guys in the next one. Remember the functions of the abelipoproteins.